Today we are going to discuss uh, lecture number. We have the lecture number uh, 3, okay, of nuclear chemistry. So today we will discuss the types of radioactive decay. First of all, that we have to learn that what is decay. So how can we define decay? What is a decay? Uh, Decay means uh, spontaneous. This is spontaneous disintegration. This is spontaneous disintegration of an atom or a particle. Okay, is called a decay. Decay also can be defined also as it is a decrease in a quantity. It is a decrease in it is a decrease in a quantity or activity. So whenever there's a decay, so certain amount of radioactive material is decreased because a new element is formed from the radioactive decay. So today uh, we have the different types of radioactive decay. So first of all, that we will learn about uh, alpha decay constant. Alpha decay. So we have alpha decay. So alpha decay can be represented with this symbol. This is known as alpha. Okay. So this alpha decay, it is represented by this helium. It is also known as helium nuclei. It has atomic number 2 and it has a mass number 4. So we can see that uh, when there is alpha decay, so there is a decrease in atomic mass and also the atomic number of the radioactive substance. For example, if we see in the equation that we have this uranium and the atomic number of the uranium is 92 and its mass is for example, if I say 238. Okay. So when this uranium undergoes alpha decay, then this uranium converts into thorium. That thorium has atom number 90 and it has atomic mass 234. And plus we can see here that we have the formation of uh, helium. Okay, helium nuclei. It has atom number 2 and mass number 4. So you can see here that when there's alpha decay, so during the alpha decay, this uranium is converted into this thorium, and there's always a formation of the helium nuclei. So you can see here that we have the 92 atomic number, okay, on the reactant site. So this atomic number is decreased by 2 units. So this is the 90. 90 is the atomic number of thorium, and this 2 is the atomic number of the helium. So the atomic number of the uranium is decreased by 2 unit charge, and the mass number of uranium, okay, 238, okay, this is decreased by 4 units. So this is known as alpha decay. Now uh, we also can say that this thorium, this is known as a daughter. This is known as a daughter nuclide. Okay, this is a daughter nuclide, and this uranium is known as uh, we call it. This is a parent. This is a parent nuclide. Again, we have another type of radioactive decay that is very important. That is number 2 is a beta decay. So this is a beta decay. So beta decay is symbolically it is represented like this symbol. Okay, this is the beta, and it is can be also represented like this. This is a -1, and it is a zero or mass number. So beta decay occurs when one neutron is converted into proton, and thus the atomic number is changed. Okay, so what happened during the beta decay? That one neutron, for example, during the beta decay, we can say that when a neutron is converted, okay, it is converted into a proton. It is converted into a proton. Okay, and thus, we can say the atomic number that we can say that atomic, okay, the atomic number is changed. So atomic number is changed. So let's explain this through a nuclear equation. For example, if I say that I have iodine, this is iodine. So atomic number of iodine is 53 and the mass number of iodine is 131. Now what happened that one beta decay process takes place, then this iodine is converted into xenon, and it has atomic number of 54. You can see that it has atomic number 54, and it is the same. We can say that the atomic mass, okay, is this iodine, and again that we have the elimination of beta particle. So this can be represented like this one. This is a -1 and this is the 0. So when we compare the atomic number here, atomic number is a 53, and you can see this atomic number of xenon is a 54. So there is increment of one unit. So atomic number from 53, okay, 153, this changed into 54. So atomic number has been increased. However, that we can see here that the mass number of the iodine is 131, and in the same way the mass number of xenon is 131. So there's no change in mass number, but there's only a change in atomic number. Now we have a third is a positron emission. Okay, number third we have, okay, you can see here that we have third decay is the positron emission. This is a positron emission. Okay, so a positron emission can be represented like this one. This is a beta, and this will be +1, and this is the 0. So +1, and this is a 0. So positron emission, it is highly a velocity particle emitted from the nucleus. So we can say that highly. So we can say that highly a velocity a particle is emitted emitted from the nucleus. Uh, we can say that it has the same mass as an electron but a positive charge. So if we represent this a positron emission through a nuclear equation, we can represent like this one, that we have this carbon, it has atom number 6, and it has, okay, if we say that it has atomic number 11, for example, so this is converted into a boron. So this is atomic number again 5, and this is 11 atomic number, and plus there is, okay, emission of a positron, and it is zero atomic number. So here that during a positron, that we can say uh, a proton is that a proton is converted into a neutron. A proton, a proton is converted, okay, into a neutron. So proton is converted into a neutron. So this is positron emission. We have also learned about electron capture. So what's electron capture? Electron captured, it is a neutron, a poor nucleus captured, that an electron from its own atom in orbital, okay, from its own orbital is captured. We have also the gamma ray emission. So gamma ray emission actually it is a very high energy, a short wave electromagnetic radiation. So during the gamma emission that we can say that when uranium converts into thorium and along with the helium nuclei, so there is in release, or we can say the emission of energy, okay, from the nucleus of the uranium element. So a gamma emission itself does not change the atomic number. So it does not change the atomic number. As the positron emission is the ejection of a positron, okay, from the neutron poor nucleus. A positron is a high velocity particle emitted from the nucleus. It has the same mass as an electron but a positive charge.